this is one of maybe 10 lessons, 10 Math 2 Plus supplement lessons. So this first semester only has a couple things like this. I think they all fall in Unit 1. So after Unit 1, we'll have a couple units where there's not a whole lot into the honors part. So, but this is following on what we learned about complex numbers. This is called a complex conjugate. Okay, complex conjugate. It sounds fancy. It actually isn't. There's not too much to it. We use the complex conjugate to get rid of the imaginary part in the denominator. You can't have an imaginary part in the denominator. It's one of the guidelines we're going to go with and using the complex conjugate to deal with it. Okay, so the main thing that we're going to do is to change the sign of the imaginary part and then multiply that to the original. So you see that if I have 2 plus 3i, which is the imaginary part here? 3i. It has the I in it. It changes to the complex conjugate is 2 minus 3i. How easy is that? Change the sign of the imaginary part. That's it. Now, when we use it, you're going to see what happens pretty quick. But let's first just tell me for the first one, which is our imaginary part? 2i, perfect. So we're going to end up with 5, what for our complex conjugate? 5 plus 2i. You see? That's all a complex conjugate is. You look to see which is the imaginary part of the complex number. You're changing that to the opposite sign. Okay. One thing, too, you may see this notation. If the expression is denoted by z, the complex conjugate is bar z. Okay? So sometimes you see the bar over x if you're talking about the mean. There's a couple other places it comes up. But we're just going to use that. When you see complex conjugate bar z, it's saying it's the bar. Essentially what we just did was 5 minus 2i, bar, and that equals 5 minus 2i. So it could be over an entire expression or just, given that this expression is z, then bar z is the other answer. It's just symbology to that. Okay. Welcome back. What is my imaginary number component over here? 4i, so let's go ahead and change it. I want you to put it in the regular order. They're trying to trick you here. Put in the order that we like to always put our real numbers first. So 1. What we just learned was the complex conjugate helps us get rid of the imaginary in the denominator. All we do is change the sign of the imaginary part and multiply it. We're going to multiply in the next step. So just looking to see what are imaginary parts and just changing that, that's what we've done. For the person that walked in late. Imaginary part here. It's the whole term. There's nothing else connected. So complex conjugate of that is bye-bye. Easy. Easy to figure out what the complex is, right? The CC. What is my imaginary number here? There's not an imaginary, right? So I only ever change the sign for the imaginary. Not the sign in between, because when they're in different order, that's going to confuse us. But just the imaginary change. So 12 stays 12. Okay. I just want to reinforce that idea. 2 plus root 6, which is imaginary? None of them. So again, just to reiterate, if it is just a real number, then I will just... So far, so good. You're like, well, what the heck? That seems too easy. What are we going to do with it? Okay. So again, anytime you have an imaginary or complex number in the denominator, we're going to use the complex conjugate. So first, for this problem, tell me, what is the complex conjugate? Tell your neighbor. See that they know. What's my complex conjugate of that? Wait. Luciana knows. Luciana. What did your neighbor say? I don't know either.
One of them said 3 over negative 6i, and the other one said 3 times 6i.
No one else said anything? Or it's a third option?
Third option.
Mm-hmm. So remember, we had negative 5i. What's 5i? When I am looking to see what I need to change, that's all I'm looking at. So forget everything else. Forget the 3, forget everything else. What's the complex conjugate of 6i? Okay. Is everyone okay with me doing this? That change anything? Times 1? Didn't change anything, right? No. We can make a special one with the complex conjugate. Watch. Negative 6i. Negative 6i. Is this equal to 1? Yeah, so it's no different. But this is going to allow us to get rid of the imaginary on the bottom. You're going to see how it happens. It's nice. It's nice how it happens. On the top, 18 negative I. On the bottom, negative 36 I squared. Oh, yeah. I squared is going to help us with that. So what was I squared again? Negative 1. So altogether we get 18 negative I over 36. Can we reduce that? Yeah. So we end up with negative I over 2 because 18 is half of 36. 18 is half of 36. Now if you were to divide by 6, you would end up with negative 3i over 6. And look, you can reduce that further, right? So if you didn't choose 18 to divide both by 18, that's okay because here you would end up with dividing by 3 and you'd get the same thing. Okay. So don't worry if you chose to reduce with a different value. That's fine. Last period when I did that, or second period, it was almost like it was more confusing because it was just its own term here. Okay. Just know that when we get into our binomials, it's going to make a little bit more sense of it. So let's try that. What is my complex conjugate for this problem? Tell your neighbor. Tell your neighbor. Marisol, what do you think? What is our complex conjugate? I like that you changed it to positive 4i. But if we have a binomial here, then we have to keep the real part to it. Okay, that's the only difference. And that was subtly maybe even a setup. I'm sorry about that. Remember, we changed that. But the whole binomial, you're going to see why in a moment, why we want to keep the real and imaginary. So again, is everyone okay with multiplying by 1? Yeah, right? Doesn't change anything. So watch. Guess what we're going to multiply by? 2 plus 4i over 2 plus 4i. Okay. Now this is where we get into a little bit of FOIL work. So let's see, 3 times 2 plus 4i. And on the bottom we have 2 minus 4i times 2 plus 4i. So this is just like the work yesterday. There's really nothing too different once you start. Once you know the complex conjugate, know what to do with it, then you just have to distribute that top 3 and FOIL the bottom one. That's it. 6 plus 12i. I want you to FOIL this one out. I'll give you a moment for that, and then we'll come back together. We're going to have a new term down here. We're going to have a new term. New set of terms. Okay. Okay, and check with your neighbor when you're done. See if you got the same or different values. Okay, Destin, help me out. Plus 12i. Well, let's do it. First, okay, no worries. So help me out anyway here. First is 4, I like that. Outer, good. Inner, minus 8i. Last. There it is. Okay. Foil it up, foil it up. All right. What do we know about I squared? It's -1, right? So we can keep going, and now we have 6 plus 12i over, let's see, what happens to these? That's how the complex conjugate gets rid of things. It's always going to have those negating terms. This is -16 times -1, so that's 16, plus a positive 4, 20. What can we reduce from all that? What can we divide out of every single term? 2. So 3 plus 6i over 10. Can we go further? See it now? What's the crux? What's the crux? Candy crux. Candy crux. Tell me the crux, you get candy. It might not be your crux. It's good to think about other people. Like, what could be the hardest part? Crux means the hardest part. If you were rock climbing, it'd be the part that's super hard. You say, that's the crux. What's the candy crux here? Give me one.
Oh, like,
yeah. Like, where could someone go wrong? Where is a detour? Distributing this or foiling it out. Okay, where's another spot? Someone else. Yeah, well.
Maybe they won't simplify it all the way.
Maybe they didn't simplify it all the way. That's kind of a goal. We always want to have it simplified, whittled down. We don't want any extra. I mean, what's another? Oh, these guys. These guys. I'll let you know. For complex conjugate, this is the one you need to know. That's it. That's the only one you need to know. That's the only one that'll come up. You always know that when you do the complex conjugate, the outer and the inner are always going to cancel each other. So some of you are going to find a really quick way to do these problems. That was good. Oop, that might be short. Oh, that has never happened in my class. That's a lie. You get an apology, Starburst, Ethan. It was what? Okay, let's do this last problem. How do we feel right now? Thumbs up, sideways down. Let me see. That was quick. Everyone went pretty good. Some people are here, and we'll do another, and then you'll all be just masters of this. So, 2 plus 3i. If there's a harder one, it might be this one's a little harder. -5 minus. All right, it's going away. 2 plus 3i, -5 minus 2i. Where do we start? Oh, what is that complex conjugate? -5 plus 2i. Okay. Now go for it. We're going to multiply top and bottom. My next reminder is, that's okay, right? Use another special one. It looks like it's going to be what? A double what? Like a double FOIL kind of problem, right? Double distribution. All right, check with their neighbor if they're all done. They look like they're giving up. Say, don't give up. We're finishing the lesson, so why don't you come here real quick? They're doing the problem. So we're using these complex conjugates. The reason why we want to get rid of all the imaginary numbers is the way that we find what the complex conjugate is, we look at what the imaginary part is, 5 minus 2i, and we just change the sign of the division. 4i plus 1, we can make that 1 minus 1. This one, let's switch the order. This one is minus 15? Yeah. So if it's negative 5i, it's 5i. If it was 12, that's not imaginary, so it stays 12. But we're only ever changing just the imaginary part. 12 is 12 because it's 12. So then what we do is, notice over here, I can multiply anything by 1. This is 1, but 0 stands for itself. When we multiply these, what we ended up doing was canceling out all the imaginary parts of the bottom. So we're going to do this problem right up here. So, 1 second, just put this down for a second. So, here was our original complex conjugate for that. We're trying to get rid of the denominator. The denominators will go. So it's negative 5 plus 2i, right? So then we multiply negative 5 plus 2i, negative 5 plus 2i, and that's where we're at, right? So why don't you get out notes and do this problem for sure? And then you might have to review with me during class. Cool? Feeling okay?
Can I copy the note?
Yeah, copy it. But we're going to do this problem right now, so I just want to get you where we're doing. So I want you to see the example. All right. Thanks for bearing with me. We got the complex conjugate. We're multiplying our special 1 times the original. Let's see. Let's do FOIL for both of them and see where we end up. Okay. So let's multiply the first 2 terms. Negative 10. Outer. 4i. Inner. Last. Plus 6i squared. Let's deal with the I squares at the end on the next step. If you did it right then, that's fine. Okay. First. 25. Outer. What do you think the inner is going to give you? Anytime you're doing the complex conjugate, those middle terms always negate out. So if it doesn't, just know that's not right. I don't need to look. Yeah, I do. Yeah, that's true. Last. Minus 4i squared. What do we know about this? I squared. Negative 1. That's the only one we have to remember. This one right here, for the complex conjugate, is the one that comes in handy. I squared is negative 1. All right, let's put it all together. I think we're going to have 2 more lines here. Let's see, I'm just going to rewrite some of this. These 2 combined, negative 11i. 6 times negative 1, minus 6. We'll combine them in the next one. No big deal. Here, what happens to these guys? The 25 -4 times -1. It's nice how most of it falls off, right? Okay, so then we go over here, combine those the negative real numbers. -16. Keep going. Can we reduce those? No way. You got an 11 in there. You know the 11 trick, but you don't know. You don't know. You can't do anything else. Thumbs up, sideways, down. Thumbs up, sideways, down. You want to see another? How about one more really quick? Okay. I'll just make it where we have to do something for the denominator here. Okay, so how about if it's this 1 over 3 plus 2i? Okay. And how about we make it 2? Make it 2 over 3 plus 2i. So if you needed another example, let's get this one down. What is my complex conjugate?
3 minus 2i.
Everyone's okay with this? Multiplying anything by 1 doesn't change it. Name of the game, don't change it. So we can multiply by a special one. Okay. So what should I multiply? What's that special one going to be?
3 minus 2.
Right? Okay, so we are going to just have a distribution on the top. We're going to have FOIL on the bottom. Distribute that top one. 6 minus 4i. I don't think that's going to change. That's probably, well, they're both even. Something could happen. Maybe there's an even number. Something could happen. Okay. FOIL these two binomials. First,
9.
outer.
6i.
Inner. Do you even need to look?
Plus 6i.
We always know that we're going to have these two terms in the middle from our outer and inner. These two terms, when we do the complex conjugate, are going to cancel. Last.
Minus 4i.
Perfect. 6 minus 4i. We know this is equivalent to -1, that I squared. So we can say 9 plus 4. 6 minus 4i over 13. Was it helpful just to see it quicker? A bit? If you had it, you had it. If you needed another one, maybe that was the path. Okay? So first step, find your complex conjugate. Second step, multiply by the special one. Third step, simplify. That's it. Maybe I'll even say fourth step is remembering, oh yeah, we gotta get that I squared dealt with. All right, I gave you like 13 minutes for classwork. I think it is up there. It's on a Moto 2 through 24 even, so you got 12 problems. And a good amount of time. I'm let you go ahead and do that. Yeah, I'll do that. Okay, just a reminder, subscribe. 250 gets a Kit Kat. Bye.